Hello, I'm Carly McAvoy, and today I'm talking about rational expressions, adding and subtracting. Actually, I'm just going to look at subtraction. Addition obviously is very similar. So in the first one we have here, we have rational expression. A rational expression is just a fraction that's got variables in the denominators. And when we have like denominators, we just combine the numerators and then we simplify if possible. Just be careful when you're combining the numerator here because you're actually going to distribute that negative sign all the way through the second fraction. So we have 7y and then minus 2y and not minus a minus 3, which is plus 3. And the whole thing is over the common denominator of 3y minus 1. So when I combine those like terms, 7y minus 2y is 5y plus 3. And then down below I have my common denominator of 3y plus 1. And I cannot simplify that, but I would if possible. That's always something I want to consider. In the second example, we do not have like denominators. We have different denominators. So we're going to find the least common denominator, restate each fraction, combine the numerators, and then simplify if possible. In order to find the least common denominator, I'm going to factor my denominators. I'm not going to factor the numerators, but I am going to factor the denominators. X squared plus 6x plus 8 is going to factor into x plus 2, x plus 4. And then I have my second fraction, x minus 5 over x plus 2. So the least common denominator here is going to be x plus 2, x plus 4, and then x plus 2, well, I already have x plus 2, so we don't need to put that in there again. The common denominator has to represent all the fractions. These two binomials represent everything that's up there. So this is my common denominator. My first term is not missing anything from the common denominator, so I have x squared minus 18. It doesn't change. My second term, though, is missing the x plus 4. So I have to multiply both the top and the bottom by x plus 4. And remember, I'm going to be distributing a negative sign through that. So after I multiply the top, I then have to distribute to get that correct. Now I'm going to go ahead and move this up a little bit. Multiply that out. So I have x squared minus 18, and then if I FOIL this, I get x squared minus x minus 20. And that's just the FOIL process you could do over at the side. And I don't want to forget about my denominator, so I'm just going to put LCD. Now if I distribute that negative sign, I have x squared minus 18 minus x squared plus x plus 20 all over the LCD. And finally, I can say x squared minus x squared goes away. I have x. I have negative 18 and positive 20, which is positive 2. And my LCD, I'm going to write out now, is x plus 2, x plus 4. Notice what happens there is I have an x plus 2 in the numerator and in the denominator. Those then can be canceled. I can cancel an entire binomial, but not part of a binomial. So what I have left on the top is just 1, and the denominator I have x plus 4. So we found a least common denominator. We had to factor to do that. We restated the numerators by multiplying by what they were missing, if anything, and then we simplified that numerator and simplified the entire thing altogether. All right, that's it for subtracting, and I'll talk to you next time.